Chapter 1. Being a short exposition about what could happen and how it would happen. And if the enemies or competitors be in the least degree favored by any slight change of climate, they will increase in numbers, and as each area is already fully stocked with inhabitants, the other species will decrease. Charles Darwin on the Origin of Species. Page 2. It is not likely that human beings could catch and destroy all sea life, even if they tried to, and of course, we are trying not to. Nevertheless, considering overfishing, pollution, and global warming, the entire system of ocean life could completely unravel within a relatively short time, and then we would be helpless spectators to a cataclysm. Page 3. The key to success for all life on Earth is biodiversity, the presence of a wide variety of species. The more advanced species, the relatively recent arrivals, are the most complex. They are also the neediest species, more fragile than the less evolved species that have managed to survive for millions of years with few, if any, genetic changes. The most highly evolved animals in the sea are mammals, whales, porpoises, and seals. Then come the fish that have backbones and fins. A fish with several fins is more evolved than the fish with one long fin. So a cod, for instance, which has 3 fins on top and 3 on the bottom, is more advanced than a flounder, which has only one long fin across the top and another across the bottom. More advanced fish tend to feed on less advanced fish. Sometimes they help each other. Dolphins need the help of less advanced tuna to find the even less advanced smaller fish they both eat. Page 4. Large fish often drive the small fish they eat to the surface, which makes it possible for seabirds that eat the fish to feed. Those seabirds then deposit food on land that feeds crabs, beetles, and lizards, which in turn become food for land animals. So, if the great variety of different species, the diversity, is reduced, it will become more difficult for the remaining animals to survive. If the top 40 species of commercial fish were to disappear, or even have their populations decline to very small numbers, this would be a grave threat to all of biodiversity. Other species would begin disappearing too, either because their lives depended on cooperation with these species, or because they used to eat those fish, or even because those vanished species used to hunt predators that were now free to roam and prosper. Page 5. In time, all fin fish would disappear. In fact, most sea animals with backbones, vertebrates, would completely vanish. Their disappearance would mark the beginning of a process in which evolution goes in reverse. In the ocean, that would mean sea life returning to conditions 550 million years ago, in a time known as the early Cambrian period, long before dinosaurs. At this time, there were no fish. Even today's small fish species, such as sardines and anchovies, are only 100 million years old. The trilobite. Virtually all of the modern invertebrate groups appeared in the early Cambrian age, including worms, clams, snails, cephalopods, starfish, urchins, crabs, lobsters, insects, and trilobites. Page 6. Once the larger, more evolved fish were gone, some mammals would die off very quickly. The dolphin, for instance, would not find its food because the bluefin tuna it used to depend on would be gone. The Atlantic bluefin tuna. Schools of tuna are known to swim near or alongside dolphins for protection against predators such as sharks. Page 8. The seal would simply starve. Elephant seals might last longer, however, because they feed on squid, a primitive invertebrate that would survive the rapid extinction of marine life. Humpback whales and other large mammals that feed on the tiny shrimp called krill would also survive for a while because they can travel thousands of miles looking for food. But since they need older whales to tell them the location of the feeding grounds, and they would likely end up competing with humans for krill to eat, eventually they would die too. Without large bottom fish to drive the small fish to the surface, seabirds would die out. Page 9. This has already started to happen in some places. Gulls and terns have been vanishing from the Atlantic at an alarming rate because of a loss of fish from the upper level of the water. Seabirds would actually be an exception to the pattern of the most evolved dying off first. Some of the most highly evolved tropical seabirds seem peculiarly built for a world with a scarcity of prey. The newest models, new in terms of millions of years, have very small, underdeveloped feet because they don't land very much, but they have very well designed, long wings that effortlessly sustain flight for long periods of time. Tropical seabirds fly great distances in search of prey. Frigate birds can stay in flight for months. They are graceful flyers, but very awkward on land. That would probably survive for a while because, though much of their food consists of fish, they harass gulls and other birds to disgorge their meals. They also eat jellyfish. Sooty terns, also with long, thin wings, can stay in flight up to 6 years, traveling long distances and scooping fish driven to the surface. Sooty terns like to feed on flying fish. The problem with these flying feeders is that once they locate prey, they dive into a school and the fish swim deeper. So a sooty tern's only chance to feed is if the fish are driven to the surface by predator fish below. If those are gone, so are the sooty tern's chances of survival. Mid-top of page 10. Birds also look for tuna, dolphin, whales, and other large fish to help them find their food. The classic example is the petrel from the Juan Fernandez Islands off of Chile, which are famous as the site of the Robinson Crusoe story. These birds rely on the spinner dolphin and eastern yellowtail tuna to lead them to bait fish. The petrel is entirely dependent on subsurface predators, the larger fish from below, and so despite its great capacity to search for food because of its strong, long wings, it would also be doomed by the destruction of the more evolved fish. In the end, there would be few survivors in the ocean. Page 11. One survivor would probably be plankton, the tiny creatures that so many animals feed on. The total population of plankton and krill is already the largest mass of protein in the world today. Without these other ocean creatures around to eat them and keep their numbers in check, the sea would become clogged with plankton, which would probably turn the ocean either pink or orange. Overpopulated, large numbers of plankton would die, leaving poisonous areas the size of small islands where they are rotting. The poison would kill off shellfish and animals, including mammals that eat the shellfish. This has already begun to happen, and more shellfish beds have been closed periodically because of these harmful algal blooms, which are sometimes referred to as red tides. But the sea could become one enormous red tide. Harmful algal bloom. Harmful algal blooms, which are also known as red tides, like this one off the coast of Alaska, appear to be increasing worldwide, according to the National Oceanic and Atmospheric Administration. Page 13. Another survivor would be the jellyfish. This ancient species dates back more than 500 million years to the Cambrian period. The jellyfish is actually a very highly evolved type of plankton. It is the cockroach of the sea, an animal little loved by human beings, but particularly well designed for survival. Page 14. We don't think much of jellyfish because, like insects, they are not even in our phylum. But whether we love them or not, jellyfish are an evolutionary success, likely to survive when more evolved animals fail. They can eat an unusually broad range of foods, and if they can't find enough to eat, they can make themselves smaller so that they will need less food. They are also resistant to poisoning and have the ability to grow new animals from parts of their body. Jellyfish populations are kept under control by the 124 species of fish and 34 other animals that eat jellyfish. But if their enemies were to disappear, the jellyfish population would greatly expand. Its zooplankton food supply would be made almost limitless by the lack of other animals to eat them. And because warmth also stimulates jellyfish growth, global warming would help the jellyfish reproduce. And in this scenario, not only would evolution start going in reverse, but parts of the food chain could start reversing too. Animals that were hunted could turn around and start eating their hunters. If the jellyfish population expanded while the fish populations were declining, jellyfish might start eating some of the fish that once ate them. A jellyfish eats by stinging its prey with its tentacles and then feeding it into its floating belly, which acts as a kind of pump that gives it the ability to travel through water. The takeover of the world by jellyfish has good potential for a sci-fi thriller, but it is not that far-fetched and very likely to happen in a world without fish. A jellyfish snack? In about 60 years, jellyfish might be your only choice if you're in the mood for seafood. Though not a popular food for Westerners, the Chinese have eaten jellyfish since ancient times. In Asia, about 425,000 tons of jellyfish are caught every year. Below is an example of a light jellyfish salad. Page 16. A few other animals might also profit from this turn of events. Leatherback turtles would do well. Like the jellyfish, which is their primary food, they are an ancient species older than most fish. Their diet is almost exclusively jellyfish. They have nearly disappeared because people like to eat them, but in a sea full of jellyfish, they would do quite well. But with no fish left to eat, humans might start going after leatherbacks and even jellyfish for food, so their chances of survival might not be great in the long haul. As evolution reversed itself, worse things than jellyfish would flourish, including prehistoric bacteria. Already, little-known prehistoric organisms have emerged in nearly a dozen places around the globe. Bacteria that prospered 2.7 billion years ago have been plaguing fishermen in recent years in the form of hairy-looking growths that constrict the throat, making breathing difficult and causing severe welts on the skin. Who knows what other bacteria would flourish in a warm, swampy orange ocean full of jellyfish and plankton? The tragedy of the seas, much of which has its roots on land, would soon spread to land. With seabirds gone, the reptiles, lizards, insects, and crabs that ate the food discarded by seabirds would die out too. A decline in seabirds would therefore lead to a decline in lizards, crabs, and beetles. The absence of those creatures would lead to the decline of some freshwater fish. And this would eventually impact land-based mammals, including us. There are many things that are scary about the idea of evolution reversing itself, but the scariest is that we, the Homo sapiens, are latecomers to the evolution game. In the 500 million years of life on Earth, we only arrived about 10 million years ago. So if the chain of life unraveled and evolution went backward, we would not be among the survivors. Page 18. This, of course, is a worst-case scenario. What could happen if we did absolutely nothing? The good part about imagining what could happen is that we can move to try to prevent it from happening. How? By changing the way we do things now. And we have the power to do that, now. But before we know what to change and how to change it, we need to understand how we got into this predicament in the first place.